All right, welcome back. In this section, we're going to go ahead and explore one of the most common distributions, and that's the normal distribution. So before we start, let's just go ahead and, for example, recall that when we're looking at continuous distributions, we need continuous quantitative variables. And that's due to the fact that we usually measure these. So if, for example, I'm looking at the amount of rainfall, so there's actual rainfall, I believe, in India due to monsoons, then if I go ahead and summarize that, the best visual summary would be a histogram. And if I go and explore this, I can see that there tends to be this very characteristic behavior, which is a lot of the values that are observed happen closer to the center, and less values are observed further away from the center, so further from the mean. And we can go ahead and also visualize that if we look at a dot plot. It's not as easy to see, but we do observe that, again, we get a lot of values closer to the center and less data points further away from that center. And that pattern occurs over and over again in statistics. Remember that the distribution is basically the curve that we believe those samples follow. It turns out that the PDF for the normal distribution has this formula. And remember that when you see the word PDF, just think of distribution or description of the behavior. And you don't really need to worry about this because same as before, we're going to be using technology to work with this PDF. The most important thing, which is not surprising to us, is that the expected value is right in the middle. That's the mean. And we also quantify the variability in our for our random variable using sigma. And so if you go one standard deviation away to the right, you're going to get what's called an inflection point. So that's where the curve changes from going downward, curving downward to curving upward. But we've already seen this in empirical rules. So this would be 2 standard deviations. And we already know that beyond 3 standard deviations, we do not expect to see very much data. All right, to go ahead and read these characteristics here, which are essentially just a summary of the pattern that you should have picked up on the earlier chapters. So let's go ahead and start with this. So if you have a random variable, like for example, what I showed you earlier, that was rainfall. So X here could be, for example, the amounts of rain. And usually, I believe it's measured in millimeters. So they measured the amount of rain in millimeters, and we go ahead and find some evidence based on our histograms that the amount of rain could potentially be normally distributed. Okay, so this sample provides evidence of that claim. And then I would go ahead and say, well, X, the amount of rain, has a distribution that is normal with the center given by mu and spread given by sigma. So that right there would be all I need to describe a normal distribution. All right, let's go ahead and take a look at our first example. Psychological and health studies often examine the amount of sleep people get per night. In healthy adult populations, so again, we're excluding people that have issues with sleep, the number of hours slept per night tend to follow a normal distribution, again, especially when controlling for outliers. Sleep needs vary between individuals, but cluster around the central tendency. Here's a model for X, which is the number of hours slept last night. That's our random variable. And they're telling me that that random variable has a normal distribution, center of 7.5, and standard deviation of 1. And I'm assuming that this is in hours. All right, and then first part says, describe the distribution of the sample. Does it agree with the stated model? So what I want to point out here is that it says sample. So where do you get the sample? You get it from StatCrunch. So go to your 3.3 data set under groups. And here I have some data for sleep. So we actually track this, right? You need volunteers or people that have been selected. And here we observe that this individual 6, slept 5.957 hours, and so on. So you can see that a lot of these numbers look very similar to one another. I mean, here we have someone who slept 10 hours. So that's different from the rest. So let's go ahead and just visualize this. So describe the distribution of the sample. Distribution, we always want center, shape, and spread. So let me go graph. histogram sleep. Whoa. Okay, so there is my sample. And again, we observe that characteristic of normally distributed data, which is a lot of the data is clustered around the mean. And then the number of data decreases as we move away from the mean. So we can actually envision the mean if you click View Mean. And you can also click here where it says Display, and you can select Normal. So look at what happened. What they did is they essentially drew a normal curve now. So we can see that it says here, normal. And the mean for this data set is 7.87, and the standard deviation of my sample is 1.1083. So from that sample, I'm basically going ahead and taking my sample statistics. And then I create a normal distribution, and you can observe it here. StatCrunch does this for us, so it's really nice. And then we can go ahead and see whether there is agreement in my histogram with that smooth pattern. And I would argue that there is very good agreement here because, yeah, there's a little bit overshoot here, but then there's undershoot here. So there's less people than I expected here, but they're fairly close. And you can see here that this is a little bit under, but then we have these right here going a little bit higher than we expected. But overall, they do seem to follow this this pattern. So this is actually very good. That's more or less what I wanted for that first part. So when it says describe, again, you need to tell me the shape. So I'm going to go ahead and say that this looks normal. The mean, the sample mean, so let me describe the sample by writing X bar. And X bar was 7.87. And my standard deviation was 1.1083. All right, and then we're asked, does this agree with our stated model? Remember that this is a sample, and if you were to take another sample, there will be natural variability. So I go ahead and say that this is actually pretty close. We claimed that the center was 7.5. My sample center was 7.87, so pretty close. Standard deviation was 1, and my sample standard deviation is 1.1. So again, fairly close. Does it agree with the model? I'm going to go ahead and say yes. We'll explore this idea further in next week of whether this is actually close enough. All right, let's go ahead and do part B, sketch the distribution of the number of hours slept. So this is where we're actually going to use our model. I'm not going to use my sample anymore. I'm going to say, well, we're claiming that I know how this amount of sleep is going to behave. It's going to behave according to this statement right here. The amount of sleep is supposedly normal, has a center of 7.5 with spread of 1. So let's go ahead and sketch that here. And what I'm going to sketch is basically what we sketched here in red, what StatCrunch sketched for us. So remember that to sketch a normal distribution, you put your number line, mark your center. So this is going to be mu of 7.5. And then always mark the standard deviation right below that. So sigma is 1. Then we're going to go ahead and put a bell curve on top like this. If you want, you can just try your best. No need to sketch it. Use one line, and you'll just get better as the semester progresses. If you want, you can go ahead and mark 1 standard deviation to the right. So that'll take you to 8.5. Go 1 more standard deviation. That'll take you to 9.5. Go 1 more. Usually by 3 standard deviations, we don't really expect any very much data. And we can observe that here. So let's mark it. Let's just see how this agrees with that statement. So if my center is roughly, right, the theoretical center is 7.5, and I go 1 standard deviation, that's 8.5, go another standard deviation, that's 9.5, go 1 more, that's 10.5. And remember that empirical rule says, so 3 to the left, that would take me to, let's see, 6.5, 5.5, and 4.5. So remember that we expect 99% of the data within 3 standard deviations. And we expect roughly 95% of data within 2. So most of our data should be here and here. And we can see that that does tend to agree. Our center is a little bit off, so that's why there's a little more data to the right. But remember that this is all based on this graph, this red curve, is based on the center of 7.87. So we did expect some disagreement there. All right, and that's pretty much it. We've sketched our distribution, and notice that this is basically describing the behavior of X. So the amount of sleep behaves like this. So if you were to take a sample, I can tell you that the values that you observed should be here in your center. All right, let's go ahead and do part C. What is the amount of sleep below 2 standard deviations? So just real quick, whenever you're finding a value, just remember that here we have our center. And then we want 2 standard deviations below the mean. So that's 1 and 2. So if you go one value, that's mu minus sigma. So that's 7.5 minus 1, that's 6.5. Then mu minus another sigma, that'll be 2 sigma. So from 6.5, go one more below, that's 5.5. So I can ask you, what value would we get if we go one more standard deviation? I did it earlier, so go ahead and take a look at that. All right, now here's a question for us. Find the z-score of a person who slept 9 hours. So they're basically saying X is 9. We observe somebody with 9 hours. Remember that the z-score is X minus mu over sigma. So let's go ahead and plug that in. That's 9 minus mu is 7.5 using our model divided by 1. So that becomes 1.5. All right, and then part E, for the normal distribution, any value more than 3 standard deviations is unusual. Find the cutoff sleep amount, which would be considered unusual. So again, you can do this just by hand. So the value, we can go ahead and rearrange this. And we get that the value X is given by, go from your center, and then you go the number of standard deviations times the standard deviation. And the number of standard deviations, remember, that was Z. So for part D, where we see Z is 1.5, that means that we are 1.5 standard deviations above. Above average or above the mean. For this part right here, E, we're saying any value more than 3 standard deviations is unusual. So that means that you want to find the cutoff point be up above 3. So that'll be 3 sigma. So plug this in. Mu is 7.5. 3 times 1, which gives you 10.5. So if we go back to our drawing here, we know that we have a standard deviation that is above 3. So from 7.5 to 10.5, that's 3 standard deviations. And so again, this would be unusual. So observing somebody that sleeps more than 10.5 hours would be unusual according to my distribution and according to my sample as well. Similar effect would be on the left-hand side. More than 3 standard deviations to the left would be 4.5. So we do not expect to observe someone that sleeps less than 4.5 hours a night. All right, that does it for this example. Go ahead and review any parts that you have questions on. On the next video, we'll go ahead and find probabilities.